welcome to our talk about automated provisioning with CfgMgmtCamp and Foreman. So today we'll present this to you, Markus. This is me, Jan. Just my background. So yeah, I'm working as consultant since 2022 at Ethics. I have some years of experience in Linux, and my focus is on DevOps topics, automation, also Qboot and Measure Boot, especially for mobile devices like laptops.
So, and about myself, I'm working as software engineer at Ethics since 2022. And my main focus I'm working on is Foreman, provisioning and host registration. And I also work a lot on our internal build infrastructure, build system. And I'm somehow responsible, I got responsible for the lead upgrades from year 7 to year 8, now from year 8 to year 9.
Yeah, so this is our agenda. I will give you a short introduction to CfgMgmtCamp, what it is, how it works. Then we have a look how provisioning with Foreman is working so far. And then we look what we made to make it work with CfgMgmtCamp. Then we have a short status outlook, and then also a short live demo. This works out. So what is CfgMgmtCamp? Basically, this is part of the EU EFI specification. So basically, it ensures the authenticity of software, which is loaded and executed by the firmware. And basically, what you want to have is some chain of trust. So simple saying that if you power on your PC and you boot your firmware, your bootloader, and the new Linux kernel, you want to be sure that the actual Linux kernel was not modified by a bad person, especially not modified remotely. And CfgMgmtCamp comes with some controversy. So first of all, Microsoft is basically a kind of CA, at least by default. So everything you want to boot with CfgMgmtCamp, with the default settings, must be signed by Microsoft. Then we have the point that currently, so if you speak of the kernel, you also have initRD, and the kernel is actually signed. But what is about your initRD? The initRD is generated on your system, and of course you cannot go to Microsoft and ask them that they sign it every time. And what's also a point is basically that this whole stuff is what brings more complexity. So you have more code, you have more bugs, and also more potential attack vectors for bad people. And let's see how it goes. So for example, there are news like that basically hardware is shipped to customers, and then you find out that basically they contain credentials, which is basically test or was planned for test purposes. So that's not good. Then you have, for example, parts like these fancy logos you can see if you boot up your machines. So there's, for example, this logo fail incident where they found out that if you just take some, I think, BMP file or something, you can manipulate it and inject bad code or even make CfgMgmtCamp not working then. Then we have vendors, same here. They say, okay, we accidentally shipped our devices with a task key. If you look in the internet, then you can probably find also the private part, which then also makes CfgMgmtCamp basically obsolete. How's it going in 2025? So at the beginning of this year, I bought a small mini PC for my home lab, and I just checked, and that's what I found. So basically, do not trust. It's an AMI test key. So yeah, thanks for nothing. Then there was also, for example, MSI. They said, okay, we have secure boot, and you can enable it in the BIOS options. But actually, we have another option, which is basically saying, okay, you enable secure boot, but we do not care, just execute without checking. Yeah, a bit surprising. Yeah, and another one, this boot hole. There was some buffer overflow issue with the bootloader, and this also, yeah, is not really good for actually using secure boot if you want to use it in the sensitive process environment. So secure boot basically requires physical access if you want to change it. So if you want to enable or disable it, or if you want to, for example, add additional keys, we will then come to this later on. And be careful, secure boot is not measured or trusted boot. So this is a bit other stuff. So secure boot is really about that you want to boot only things which are signed and verified on the machine during boot up, that you can be sure that you really have the binary booted you want to have. Just some short basics about signatures. So basically you have your blob or your data. So for example, think of your Linux kernel, and you can calculate then the hash out of it. Then you have your private key, do some encryption on it, on the hash, and then you get a signature. This is then just stick to your kernel, and then you end up with this bundle. And if you then later on use this and you want to boot, you can then simply take this data blob, take the signature, and with the public key, and what's the name saying is publicly, the public key is available to everybody, also on the system. You boot this file, you then receive the hash, and if you then also calculate the hash of your data and they are equal, then you can be sure, okay, this piece of data was not modified. And the important thing, so if you talk about secure boot, we talk about certificates and yeah, just TLS certificates. So basically the public key portion is part of the certificate. Here we can see on the Linux system how this looks like. So here we see we have the kernel, and with the PE sign tool, we can simply check what's the actually, or is there a signature available, and get some information. So as we can see here, so SUSE was basically signing my kernel. And here we have EVI binary, which is called shim. We will come to this quite soon, which is then basically signed by Microsoft. That's what I already told you at the beginning, that Microsoft is the certificate authority, at least by default. How can I check if secure boot is on or not? So of course you can check in your BIOS options, but you need to run on UEFI. So this is not available for legacy BIOS. And for example, with modutil, you can then simply check if your secure boot is enabled or not. How does it work? So first of all, you have your UEFI firmware, and you have this platform key, or in short PK. So this is basically the root of trust. It's a self-signed certificate, and this is issued by the actual hardware vendor, and this is embedded in the system, for example, on your mainboard. And this establishes the trust between the hardware vendor and the actual firmware which is running on it. So on the next step, we also have this key exchange key, and this is basically also a certificate which is signed by the platform key, and this establishes trust between basically hardware vendor or the firmware part and the operating system, which should then be booted. And if you want to change the key exchange key, you need the
actually platform key. And if you are lucky with this test key, then you can do it by your own. But yeah, as said, that's not the idea behind secure boot, at least not in this case. And if we then go down this list, so we have this platform key, key exchange key, and here we have the DB and DBX. So this is basically the signature database, and this database contains certificates of third-party UEFI components and, for example, also bootloaders. Same here, if you want to modify something there, you need a valid signature of the key exchange key. And then we have also the DBX, which is basically used to revoke software which, for example, is known for some vulnerabilities or bugs. And then if you add, for example, if you do an entry or add an entry there, then you can block also things from being booted. And now we come from this part also to your Linux system. So for example, we look here at Ubuntu. So as said, we have the platform key, it's going down here. Here we have the DB signature database, and there we have a certificate from Microsoft. And if you want to boot your Linux, then you will see there is a shim binary. And as you can also see from this graph, or from this picture, basically this is signed by Microsoft. And what does this shim? So basically this shim is for somehow decoupling from this part, which is coming from your distribution or distribution vendor. And as you can imagine, so grub binary and your kernel are regularly updated. So they are signed by the distributor quite often. And to not always need an update, a firmware update, you then simply have this shim here, because this needs to be signed once for every distribution. And with the actually certificate of the distribution vendor, you can then verify that you can use the bootloader and the kernel. One thing which is quite important, you are also somehow locked then in the state. So for example, if you have your Linux system running and want to, for example, kexec, another kernel, this won't work because, basically, for example, if you want to boot here, I don't know, a SUSE kernel or something, then there is no SUSE shim involved. So what we only have is here then Ubuntu, and therefore it's blocked. Just a short information where this shim is coming from. So basically there's a GitHub repository, and so all of the major distribution vendors then take their shim binary. They need to provide a lot of information. So if all of the CVEs are fixed, which are known, always using the latest shim code, whatever. And then they have some kind of checklist. And if everything is okay, then this gets signed by Microsoft, and then the distribution can take the shim package and provide it as a package to your system.
Okay, so same for our presentation, like for Ebut's presentation. So should we skip that slide? So do you all know Foreman? Yeah, okay. You can do everything with Foreman. That's in short. Oh, check pause. 2. Okay, here we are. So basically now let's have a look at provisioning with Foreman, network provisioning with Foreman, how is it is so far. So you have your firmware here, and you have a DHCP file name. Hopefully Foreman sets a DHCP file name. And the DHCP file name points to a grub in shim binary, or shim binary, let's say that. Let's assume in this case, it's an Alma Linux shim or grub binary. So then basically the firmware loads the shim or grub, The grub then fetches the grub2 configuration also from the TFTP server and fetches the kernel and the init.rd. So, yeah. So here is an example of the grub configuration. Here's the kernel specified and the init.rd specified. And then the grub, and here we talk about the Alma Linux grub, boots the kernel. And now we are in this example running on a SUSE host. And you can imagine this will not work. We have CQ boot enabled. Sorry, I won't boot your system. So, but let's have a look now at this. So we have the DHCP file name option that specifies the shim or grub to boot. So in the case of CQ boot, the shim, it's always the shim. But and this points basically to the TFTP root grub2 shimx64.ev binary. Okay, so but let's have a look at this shim. Okay, it's Alma Linux shim. So, but why is it Alma Linux? Okay, basically because our system, the Foreman server, is an Alma Linux system. And that's the end of CQ boot. Why is it sometimes skipping slides? No matter. And this is the end of CQ boot with Foreman provisioning, network boot provisioning so far. So I have different hosts with different operating systems, but every operating system gets the same shim. And this will not work. And our idea is now we provide host-specific network boot files. We have different hosts with different operating systems, and we provide different shim binaries for the operating systems. But okay, so we want to do this, but we do not want to do any harm if you do not care about CQ boot. So everything should work as before. So yeah, no problem. You do not use CQ boot, you do nothing have to do. Just keep on going as it was before. Then also, Jan already told there are problems with leaked keys, revoked certificates. So yes, it could happen that from one operating system to the other operating system version, a key gets revoked and we have to handle that. So we definitely have to consider this and keep add a possibility to keep the boot files and the kernel in sync for the operating system versions. And also we were thinking about the workflow. So we want to do chain loading. We always want to boot from the network. Then we want to chain load the bootloader from the local disk. There was a lot to consider because you do not want to get locked out in case you. So what I want to say is we cannot skip network booting. We always have to boot our network. Otherwise, if you want to rebuild a host, you cannot do that anymore. So then we were thinking about, so what do we need? So, okay, we want the OS version specific bootloader files. Yes, we need the name of the operating system. We need the version of the operating system. We know that for every host with Foreman provisions. And we also need a file structure on the TFTP server for the host specific boot files. So, but what is a host specific or the most host specific criteria we could imagine? And we found, okay, let's use the MAC address of a host. And then we need to set the DHCP file name option for the host specific shim. But we already said we do not want to change behavior if you do not care about CQ boot. So we wanted to add a new PXE loader to specify the host specific boot file name. So there are two implementation details we want to share with you. So we need operating system version specific boot files for all operating systems we want to deploy. And we call this directory the bootloader universe. So the universe where all the bootloader files are.
So we have a bootloader universe inside the TFTP root. It's a specific structure chosen. And all in common is we have the operating system name and operating system version, and also a default version. So if the operating system version is not provided in the bootloader universe, the boot file name will point to the default version. And so we prepared the structure to be able to add boot files for other PXE loaders, despite PXE grub2, and also to add other architectures, despite ARMD64. And to simplify things, also a detail, we switched to using a common file name on the Foreman side. So Foreman always accesses boot.ev or boot-sb.ev. Let's point the DHCP file name option to this file. And they simply symlink to the shim and grub, how they are called, because every operating system vendor can have different names here. So for SUSE, we have grub.ev and shim.ev. For Ubuntu and a lot of other systems, we have grubx64.ev. And to unify that, we added these common names. So, okay, this is the universe where all bootloader files are. On the other side, we need a directory structure where we store the host-specific bootloader files. And for this, we added to the TFTP root directory a host config directory, which basically holds bootloader files. And as you can see here, symlinks to the bootloader files for specific hosts, or for all the hosts, better to say. So why are we using symlinks here? One reason is space. Okay, if I have hundreds and hundreds of hosts, I don't want to have hundreds of files and megabytes lying around. One is enough, one copy. The other thing is, we already talked about certificates being revoked and requiring OS version specific bootloader files. So for example, let's say in Alma Linux 8.5, there's an CVE, and they revoke the certificate they used for signing, and then Alma Linux 8.6 comes out, and they use a new certificate, and you put those files into the default directory in the bootloader universe. Then every host is using this directory if the version doesn't match with the host, with the version directory. And what happens? Alma Linux 5 hosts, 8.5 hosts cannot boot anymore because there's a shim mismatch. And for this, you can specify also the version directories here. And if this is the case, that the certificate gets revoked, you have to re-link to the proper boot files. In practical, you can simply click enter build mode, exit build mode, because currently there is no rewrite TFTP structure button, and then the symlinks get updated. So, and here we can see the DHCP file name option, DHCP leases, pointing to the host config directory. Okay, so short overview about development and status. So how it started. First thought was, could we provide our own shim containing all certificates for all OS vendors? So yes, we could do that, but we have much more work to do than simply doing this. And probably we would not get our shim signed. Then Jan created the first RFC in March 2023 in the Foreman community forum. And after a lot of work and reviewing, thanks Nova to you and your team.
Thank you.
The PRs got merged and will be part of Foreman 3.14 and are already part of Ocarina. So the ethics downstream product since version 6.9. There are also some limitations in this approach. So first, okay, we use the DHCP file. So Foreman must orchestrate the DHCP server. And also, yes, up to now, the bootloader universe directory must be filled by yourself. So there is documentation. Have a look at the Foreman docs. You will be told where you can find the shim and grub binaries for the operating system vendors, for the most common operating system vendors, and how to download them and how to extract them and how to move them into the bootloader universe. And also, it's not done yet. So you can use it, but there are some discussions still ongoing. One discussion is, during development, we found out that every OS vendor patches its shim and grub differently. So in regards of chain loading, if you boot the shim, load the shim, and it loads the grub, and you want to make the grub exit from exit 1, then Debian, for example, behaves differently than the other OS vendors. So we were already thinking about the solution, and we already have a pull request open. Our preferred solution now would be to boot the grub over the network and then load the local disk grub 2 configuration, because chain loading here or exiting the grub breaks for Debian, for example. All other OSs work, but Debian, yes. Please.
And officially, I think it's not, so chain loading command is also not supported by grub with in the lockdown mode. So if secure boot is enabled.
Yeah.
But for strange reasons, some support it, some not. And yeah, you need to find some solution which works for basically all.
Thanks, yeah. Okay. Should we have a look?
Yeah,
How much time is left?
For live demo, let's
That's
see
20
if
minutes.
it works.
That's the reason why I wanted to mirror my screen again, because okay.
So just
So-
some information to our setup here. So we have a Foreman, which is a little bit older. It's not the greatest. But we patched the actual secure boot functionality, and we also applied patch for the actual libvirt compute resource, because we use libvirt as compute resource here in this case. And there's also a patch applied, which is taking care of the local grub configuration boot workflow. But we just show to you. One size.
One side, yes, thanks. Thanks.
Sorry. No way.
Beautiful.
I like the So, first of all, before we start, let's have a look at our bootloader universe here. So here we have configured boot files for Debian and for Ubuntu. Also, symlinking is possible inside there. You see files are located in Ubuntu 22.04, but the default folder symlinks there.
Yeah, will make sense if we show now what happens if you want to deploy Ubuntu 24.04. But let's start with some Rocky Linux. So basically, you see we do not have any binaries here for Rocky. And so now we show what happens if secure boot is enabled, but we do not use the specific boot files for Rocky. And remember what we see here right now, as there is no Rocky stuff in the bootloader universe, we just loaded the default shell on this system, and this is an Alma system, and therefore we now get bad shim signature, so we are not able to boot the Rocky.
Is that 8 or 9?
What, Rocky?
Yeah.
9.
8 works.
Okay.
Show it.
8 works
Okay.
with an Alma Linux shim.
No, not with shim from Rocky.
Yeah, but this is the case where you're showing is I do not have Rocky configured in the bootloader
yeah.
universe,
You're
but
gonna
no
do it.
chance it won't boot.
Rocky Linux 9 just doesn't work at all. Even
I'm good, but I'm using the H shims, I think.
I haven't tried that. Yesterday didn't work.
I'm not secure good unable to.
But nice, people are using it.
Well, I mean, I started to follow it last week, so that's why I'm hopefully mistaken.
That's good.
You see that we have exactly the same problems.
And especially in the beginning of development, it was really, really frustrating and confusing because the distributions. So looking at Alma Linux, Rocky Linux repositories, you have a pulp instance listing only the most recent grub and shim files. Okay, cool. But looking at Debian, you have about 10 different grub versions, and you can imagine not the newest grub is working.
Yeah, we had some hard times.
Yeah.
As said, especially if every vendor patched their binaries a little bit differently. So
Okay.
yeah,
But we saw Rocky Linux doesn't work.
not working. So now let's make it working.
But it's interesting that it works because I don't get it to work with Debian and an older Foreman version at work.
Yeah. This is the feature we added. So you have to use the recent version because we patched Smart Proxy to provide the files. We patched Foreman to set the DHCP file name.
Okay.
Yeah.
But will it later be possible to use it with an external DHCP server which is not managed by Foreman?
You can use it. You can use it.
Why not? Why not?
Yeah. So
It's just difficult. You just need to reproduce
the
everything that
implementation,
Foreman does.
the implementation is
Because-
how it is you use no
I thought because it was listened under limitations that DHCP must be made by Foreman.
Must be managed. Yes. Yeah.
Yes.
Yeah.
At least to have the full experience. Yeah.
Yeah.
I mean, the bottleneck is really this DHCP file name option, and
Okay.
this is something you need to set for each individual machine.
Yes.
What you can do if you have a network full of only, for example, Debian systems, then this could also work because then you only need to point to this Debian shim, and this is the same then for all the systems. But if you want to have some Ubuntu system in it, then it will also get, in this case, the shim of Debian, and then it won't work. And if
So
you want-
what you can do when Foreman doesn't manage the DHCP address, but you have a DHCP server, you manage this DHCP server. You can say, okay, I have a DHCP lease for MAC address this, and I know this is a Debian host, and then I point the boot file name of this host not to the shim in the host config directory, because there won't be a host config directory generated, or will it? I don't know. I have to investigate. I never investigated the case. But you can at least point the DHCP file name to the files in the bootloader universe directly. So this is what you can do.
Okay, but that means I must make it per host by myself, right?
Can you use DHCP vendor identification for grub?
Can I use
Can you use DHCP vendor identification? Like a DHCP client can say, "Hi, I'm DHCP client something something," and you can, based on that, reply something else on your server. So if a grub on Debian says, "I'm a grub Debian," and a grub on Ubuntu says, "I'm a grub Ubuntu," you can ship the different files based on that instead of the MAC address.
Definitely that would be possible, but you have to implement stuff, or you have to find a DHCP server that is that provides the option to configure the DHCP file name based on that information.
Every DHCP server.
I don't know.
ICDSP doesn't switch.
Yeah, you can.
Infoblox does. Infoblox does too.
Yeah.
I might.
Probably some more of them.
But the problem is that we have to.
Yeah, it only works if grub would actually identify differently on
Yeah.
different
Yeah.
files.
Yeah. Exactly.
But then it's even too late. But if Grub is asking for something, then you already loaded the shim, and then you already log to the actual.
Yeah, then you're fucked anyway.
Yeah.
And it's too late to unfuck it.
Rewind for 2 minutes.
No problem. Can you show this release for
The DHCP list file.
Yeah, so we know what configurations.
Jan, could you help me with the locating?
On this, this. Sorry.
So here it is.
Yeah. Where you see the configuration that it writes out to the host config, etc. This is why you need it managed.
Yes. So and what's so now you see the configuration. So it's pointing to a shim binary root-sb.ev in the host config directory. But
Two E's in tree.
oh,
You sure?
thank you.
I think so.
Yeah. That's the problem with not
Yeah.
So now
Don't be confused. We just used symlinks here that we know Rocky is
Yeah.
actually so behind. It's
I wouldn't want to access it with the MAC address. So if you have a look here, it says, yes, I have my host config directory, but it's basically pointing back to the default grub2, grub x64, and shim x64. So it's not working. It's unbalanced. But now what we can do okay. Valid input, not seeing the screen directly.
Yeah, but use rsync.
Get the file.
Yeah.
Yeah,
Egal.
Egal.
thanks. So we've already provided all shim and grub binaries for Rocky in the root Rocky directory. Now we copied it over to the bootloader universe.
And what you actually need to do, so you need to get the shim RPM and grub RPM extracted, and then
So now we have the files for Rocky here. Then I can go. Oh. So, yeah. I can go on my host. Hopefully I click not on delete now. And say cancel build. And say now I want to rebuild it. Which basically also rebuilds the TFTP file structure.
Can you show me the template? FTP template. You can show that really well.
Camp. Yeah.
As we are now in the build mode, it's
Wait a moment.
basically
Let's finish this and then we should. Okay. So. Now again, look at that directory, and yes, they're pointing to the Roku files. And now if I go to the right window for the VM, is it? Yes. And repeat again. Yeah, it's taking so much time, it works.
yeah.
No message, good message.
Yay!
Yeah. So, and for the next thing, so we already prepared a Ubuntu 24.04 host, and we installed it with the current setup. So basically,
Because there is no question, can you show the command line again?
Command line, yes.
Is there a reason why both boot.dfi and the group.dfi are both directly synced to the profile?
Yes, yes. The reason is we use I don't know the library again. It's a file utils copy command, and these create symlinks with this command for all 4 files in one statement, and that's the reason the symlinks are always pointing back to the origin. So we do not copy them over and then symlink again, because we want to save place. So we want to have each binary only once. And then the copy utility creates a symlink to the origin. Yeah. Yeah. So you would expect to have a symlink from here to here, from here to here. Yes, that's not how the copy command works. That's the reason. So just how the Ruby command works.
You saved 2 lines.
Okay, Ubuntu system.
yeah. So as said, Ubuntu 24 is already deployed, and now we do some kind of chain loading. So it's actually not chain loading because we do not use the chain loader command in grub. What we do is basically, if you can press E and show it here, you basically check for the ESP partition and look for the existing Ubuntu grub configuration from this.
Wherever.
Yeah, it's a bit almost down. Yeah.
Just believe there is grub in it.
So current setup is we have a Ubuntu 22 grub and try to load the config from this in order to boot the Ubuntu 24 kernel.
And as mentioned, provisioning worked fine.
Yeah. We already booted a Ubuntu 24 kernel, Ubuntu 22 shim and grub. So let's boot it. So let's boot from this. Escape.
I'm not in the window. F10. I tried F10, it didn't work, so maybe I'm not in the window. Oh. Where am I?
Just restart it.
Over X. Yeah. Now I have my cursor back. I can restart.
And that's something we just detected. So when we're comparing this demo, so we see that somehow there's a problem with actually, I don't know, parting the grub config from disk for this Ubuntu 22 grub binary. It's not a secure boot issue because, as said, we were already booting the installer kernel. But we thought this is a good example to show, okay, what happens if we provide the actual Ubuntu 24 shim and grub.
So as you see, we have the entries in the files in the host config directory pointing to the default directory, where basically the Ubuntu 22.04 files are. And now I can copy the correct files. Exactly. So now we have also the 2404 files there. Now again, if I go to my hosts, because it's already deployed, the host, I set in the build mode. I cancel the build mode because I do not want to reinstall it. I only want the TFTP configuration to be redeployed. Yeah. Now we see they're pointing to the 2404 directory. Google. And it's working.
But we do not know exactly why.
It's but for the future.
Did they change it?
Yeah.
Okay.
Did they change it?
It's not secure problem.
No, we verified
It's
it.
a.
We already booted the Ubuntu 24 kernel and the Ubuntu 22 for installation.
True.
Yeah.
Loader checks against a certain signature.
Okay. So
It's
so
very
Yeah.
weird.
Yeah. Over time, do you have anything else to show? Or just question? I mean, we can continue. Just
Yeah, maybe we can just show the last one.
Yeah.
Because I mentioned that basically Microsoft is the certificate authority. So what does it mean? Am I totally lost to Microsoft? So basically what you can do on your system, you can put your system in setup mode. Then you can create your own key pair, and you can enroll them. And then of course you need to sign your kernel, and you can even then put your kernel and init together. So you have one EV file. It's basically an EFI stub kernel init. This is one file. Then you can sign it with your own key, and then you can boot it directly by firmware or by some bootloader, which, for example, System dboot supports this. And yeah, there's also a nice tool. It's called SBCTL. So this tool is especially for you boot in setup mode, and then you can easily create all needed keys or key pairs. And also this helps you in signing your files you want to boot. Yeah, that's it. Questions?
You mentioned something about patching libvirt.
Yeah. So we have this POC libvirt plugin installed because we run on a server and all the hosts you just saw are libvirt virtual machines. And we want to have secure boot enabled. So we needed to patch this compute resource in order to make libvirt use UEFI instead of legacy BIOS. But there's also upstream available, so yeah.
it's already in Foreman developed and will be available with the security features in V13. But our setup here is based on a Foreman E11, and we patched the features in. So you do not have to patch anything. Just use it.
Oh yeah, memory template for
Yeah.
one machine.
So for the Rocky Linux machine.
Yeah, it doesn't matter. Any one of them.
What template?
It's you,
This one, yeah.
Yeah.
and that one.
Ah, then.
So this is the template for the build mode. So build mode is enabled for this machine. And basically this is just the default template.
Yeah.
What we patched is also then for the Ubuntu, for this local boot. Maybe you can for the Ubuntu.
Yeah, these.
It's also still in build mode.
No, it's not the build mode.
Mesh out is the Ubuntu system where we should hook out of build mode.
But it is out of build mode.
Can you check?
Can it be that I set it to build mode and canceled build mode again?
Yeah.
And that regenerated the template and
Yeah.
not regenerated it on canceling?
Good question, but normally it should be the
Yeah. But I assume it must be the second build mode which triggered.
Fix something there as well for the auto installs.
So there's
Or are you using a something that patches something?
Maybe that's a question I can redirect to Bastian in the back, because it's I assume it's more a general question about Ubuntu auto install.
Yeah, so I've had a lot of issues with the auto install. Lots.
Welcome to the club.
And insecure boot as well on Lenovo laptops and systems and whatever, right? And now also on the Fit and VMware. But the only way that I can get the auto install to work is by replacing the standard template where it puts in a file that it sort of tries to download somewhere with a manually downloaded file, parts hard-coded in the template. But from looking at the template here, it's downloaded from somewhere. But then I wonder, did it actually download something?
Maybe we should be more specific with the machine we have here, because it's basically an Ocarina running Foreman 311, and we removed the UI, the Ocarina skin for company management. It's easier for us to set it up this way than deploying a plain Foreman and applying all our configured
Yeah.
operating systems and stuff like that.
Then this has to be for desktop, correct?
you mean Ubuntu?
The
Yeah.
Ubuntu system.
Is it the same?
Stage. But I remember we had some issues with Ubuntu 24.
Yeah, there was some, I can't remember.
Within the ISO, the Ubuntu server ISO, it's fine.
So, yeah.
Yeah.
And it's the server version works, so let's put version down.
I think the server version is also broken. And you could type fix and build your own. The latest one is the right one.
Yes.
Yeah. That's related to what you said before. The only file that we talked about immediately at the beginning of the image camp. Trying to download the open source stuff.
No. It has to do with the bootloader, the file that has to load. Ideally, it's those things.
We can connect with that and talk about that.
So you should find at least all necessary.
Yeah. So there are also the pull requests, so the RFC and yeah, and the pull request for the documentation already merged for Foreman, for Smart Proxy. Where is the pull request for the installer? Missed that one. Okay. Those two are improvements that are still open. The 10.247 is about loading always the local disk structure configuration. And the 10.207, why is this number smaller? This is the PR you can.
I cannot remember numbers. I cannot remember. You can see it. But the point is, we work on that, we get it settled and get everything working smoothly also in Foreman, or yeah, it is already in Foreman partly, and
we keep improving it.
Yeah.
Further.
But for now, you still have to manually put the files.
Yes.
But that is also into a pull request. That is coming?
No, not
because it's really difficult. You basically, with every new OS minor version, you would have to verify if the files are working from the previous minor version. If not, I have to find out which binaries are working, and especially for Debian and Ubuntu, it's sometimes an effort. So yes, there is what's called.
Yeah, there was some idea to bundle all files needed and then put it in some image registry, and then you can just download it, and then you have everything together. But this is basically, I'm not sure if this will fly, because it's also maintenance effort. But a good idea would be really to say, okay, take the installation medium, for example, extract everything you need, and then put it there that you do not need to fill the bootloader universe directly by yourself.
Okay, but then if you non-secure bootloading, you download the kernel and the init.rp from your repository. It gets a hash, right? But those shims are also stored in the same repository in most cases, right? Why then not use the same download mechanism for your shims, so that if the operating system minor version changes, the hash changes, your already configured hosts, they have the configuration until you rebuild them, of course.
Yeah.
They have the configuration that is working with the old shim, but the new hosts have the newer version already. Is that kind of solution?
Would be a possible solution if it would be that straightforward, because now, so we at Artix, we also focus on Debian and Ubuntu. It's no solution for Debian and Ubuntu, because I cannot rely on, okay, in the repository where I have my files I download, there's also one shim with that package, and I can download this and extract it. So yes, okay, it's one shim package. Yeah, but there are 10 grub packages, and you have to identify which one is the correct one that works for booting with the minor version now. So it's really complicated.
So basically, we can think about really, if we have some sources, you need the kernel, you need the init.rd, and probably you will also find the sim with the grub package along with it. But that's the next step to actually work on extracting these then. So for the first draft, this was the easiest way to say, okay, we just assume we have everything available. You need to do it manually, but you need to do it once at least. I mean, you do not need to extract shim every day. But for the long run, maybe we can think about automate this. Yeah.